Bismillahirrahmanirrahim. Hello everybody. This is a video about arctangent functions. This is a well-known, I think, equation. So let x and y be a real number. Prove that arctangent x plus arctangent y is equal to pi over 2 if xy equal to 1 and x positive y positive, equal to arctangent x plus y over 1 minus xy if xy is less than 1. It's equal to minus pi over 2 if x equal to y and x negative y negative. It's equal to pi plus arctangent x plus y over 1 minus xy if xy strictly greater than 1, x positive, y positive, equal to minus pi plus arctangent x plus y over 1 minus xy if xy positive, x negative and y negative. I mean here x times y x times y greater than 1. So we will start by this one, then this one. The others will be deduced from just these two first equation. Let us start by the first one. So we prove that arctangent x plus arctangent y is equal to pi over 2 if xy is equal to 1. Let us consider in this case f of x, which is equal to arctangent x plus arctangent y, but we are in this situation, so xy equal to 1, y equal to 1 over x. X is different of 0, strictly greater than 0. If x is equal to 0, arctangent 0 is equal to 0. Arctangent y, if x is equal to 0, it will be equal to 0. In this case, if x or y are equal, both of them equal to 0, we are in this situation. So we are here. Arctangent 1 over x. If we take the derivative, we take f prime of x, f prime or x for here for x positive, we are in the first case, f prime of x is equal to 1 over 1 plus x squared for this one, plus 1 over 1 plus 1 over x square, the derivative of 1x, I mean minus 1 over x square. This is equal to 1 over 1 plus x square minus, here we have x square, with this x square it turns to this formula, which is equal to 0. So f prime of x is equal to 0 for all x positive. This means that f is constant, f of x is equal to a constant. How we can determine the constancy? It's sufficient to replace by x equal 1. 1 fits with this condition. So we have f of 1, this is equal to tangent 1, arctangent 1 plus arctangent 1, pi over 4 plus pi over 4, which is equal to pi over 2. So we proved this first result. We have the sum of the two arctangent x plus arctangent y. This is equal to pi over 2 if x, y equal to 1 and x positive, y positive. How about the second? for the second I prepare here a graph. This is the area where xy is greater than 1. This area, this is the function y equal to 1 over x. Here y equal to 1 over x. Here we have x negative, y negative, but xy is greater than 1. Here we have xy greater than 1, x positive, y positive. And this area, the area which is dashed by the red lines, is the area when where xy is less than 1. For the second we should prove that arc tangent x plus arc tangent y equal to arc tangent x plus y over 1 minus xy. If we take the tangent, both this equation, from this side we have tangent arc tangent x plus arc tangent y. This is equal, property of tangent equifunctions. You can consult a previous video of mine, you will find this proof. Tangent of alpha plus beta, this is equal to tangent alpha plus beta over 1 minus alpha beta. So in this case we have tangent of arc tangent x plus arc tangent y, so it is equal to alpha I will repeat the formula. This is wrong. We have that tangent alpha plus beta, this is equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So I wanna apply this formula to this side, then to this side, which is strictly equal to x plus y over 1 minus xy. If we apply tangent, we compose by tangent both of the equation. From this side we have tangent arc tangent, I will call it alpha, and arc tangent y beta. So we have tangent of arc tangent x, which is alpha, plus arc tangent y, which is beta. This is equal to tangent alpha, I mean tangent of arc tangent, the function and its inverse, so this is x plus y over minus xy, 1 minus xy. If we compose from this side, we will find x plus y over 1 minus a. So the tangent of this side is equal to the tangent of this side. This is the most important information till now. I will repeat this idea. From this side we have x plus y over 1 minus xy. This is the tangent of arc tangent x plus arc tangent y from this side, and this is equal to the tangent of arc tangent x plus y over 1 minus xy. From this side we have x plus y over 1 minus xy. So they are equals. This means that the tangent of the first is equal to the tangent of the second. And we know from primary higher school that if we have tangent x equal to tangent y, this implies that x is equal to y plus kp, k in z. We have actually equivalence if they are equals. In this sense, This means that arctangent x plus arctangent y is equal to arctangent x plus y over 1 minus xy plus kp. We would like next to prove that k is equal to 0. To do this, what we can do, we can just prove that this angle is between minus p over 2 and pi over 2. Why? Because we know that arc tangent x is less than pi over 2 and greater than minus pi over 2. Arc tangent y is less than pi over 2 and greater than minus pi over 2. If we take the sum between the two arctangent, we will get less than pi and greater than minus pi. If this is the situation, we cannot deduce that k is equal to 0. What is the trick? The trick is to try to prove that the sum is actually between minus pi over 2 and pi over 2. A manner to deal with this question is to prove that the cosine is positive. The cosine is positive. Here the cosine is positive. The cosine of what? The cosine of arctangent x plus arctangent y. If we prove that this cosine is positive, this means that we are actually between the sum is actually between minus pi over 2 and pi over 2 and not minus pi. This will be sufficient to say that k is equal to 0 and that x is equal to y. Since we have equivalence, this means that this equation is true. So the most important thing to do now is to prove that the cosine of this sum is positive, which means that this angle is between minus pi over 2 and pi over 2. For this case, we have no problem since the arctangent is between minus pi over 2 and pi over 2. Since both of them will be between minus pi over 2 and pi over 2, this means that k is equal to 0. So, cosine arc tangent x plus arc tangent y, this is equal to cosine arc tangent x times cosine arc tangent y minus sine arc tangent x times sine arc tangent y. And this is equal to, we take cosine, both cosine as a factor, we get cosine arc tangent x and cosine arc tangent y times 1 minus, we divide sine, both of them by cosine, this sine by this cosine and this sine by this cosine, we get here tangent, we get arc tangent, just a minute, we get here tangent of what? Of arc tangent x times tangent of arc tangent y. But this is equal to x and this is equal to y. We are in this situation. This means that x and y are negative. If they are negative, so 1 minus this product is positive. This is positive, and here what we have cosine of arc tangent x and cosine of arc tangent y. But previously we know that cosine arc tangent x is between minus pi over 2. This means that this is positive, and arc tangent y is between minus pi over 2 and pi over 2, which means that is positive. At final, this is positive. Which means what? Which means that the sum, this angle is actually between minus pi over 2 and pi over 2. This is way. We can we have another way which is as follows. We know that cosine of arctangent x, this can take a form, so we have a formula. I think that this is equal to 1 over the square root of 1 plus x squared. Cosine of arctangent y, the same thing. This is equal to 1 over the square root of 1 plus y squared. Sine is equal to this is equal to x over 1 plus, I can write this or this. This is the second method to prove that the cosine is positive. We have cosine arctangent x. This is equal to 1 divided by 1 plus x squared. And sine of arctangent x, this is equal to x the square root of 1 plus x squared. So if we apply this formula to both cosine for arctangent x and cosine for arctangent y, and sine of arctangent x and sine of arctangent y, we will find 1 plus x squared, 1 minus xy, 1 minus xy over the product of positive number. And since we already suppose that xy is less than 1, this means that this is positive. They are two ways at least. Since we proved that the cosine is positive, this means that k is equal to 0, which means that x is equal to y. This proves this, for this I mean alpha and beta, not the same y. A and b, this proves that this is plus kp. For this, so we have, if the tangent of A is equal to the tangent of B, we have this. But since A and B, both of them is between minus pi over 2 and pi over 2, I repeat constantly these phrases, important phrases. This means that k is equal and our equation is true. Now it will be very quick. For minus pi over 2, we will do the same thing at this case. The same thing at this case. But we will take, since they are equal but negative, we will take x equal to minus 1. So x equal to minus 1, y is equal to minus 1, and we will get minus pi over 4 minus pi over 4. The sum is minus pi over 2. The constant, we take the derivative, is equal to 0 for x negative. It will be exactly the same thing here, just by symmetry we will deal with the negative. How we can do in this case? So this is an important case, but the last one will be done similarly to this case. Now, suppose that xy is greater than 1. If xy is greater than 1, this is equivalent to say that 1 over xy, which is equal to 1 over x times 1 over y, is less than 1. X positive, y positive. So 1 over x is positive and 1 over y is positive. We can actually apply exactly this equation. This is true because this 2 verifies the condition, the supposed condition. Here we have x, any given x. We will take them from this case. We are here. So they verify the first one. Then arc tangent 1 over x plus arc tangent 1 over y. This is equal to what? to 1 over x plus 1 over y over 1 minus 1 over x, 1 over y. Abracadabra. Here we take here, so we have x, we have y, so x plus y, x plus y. Here we have x, y minus 1, and xy will be cancelled with, so here we have x minus 1 from this side. The arctangent, so here we have the arctangent of this, which is equal to the arctangent to x plus y over x y minus 1. But here what we have, here we have arctangent 1 over x plus arctangent 1 over y. When x and y are positive but y is equal to 1 over x, the sum of arctangent x plus arctangent y is equal to arctangent 1 over x is equal to pi over 2. So this is equal to pi over 2 minus arctangent x. If we take the sum, it will be pi over 2. And this is equal to pi over 2 minus arctangent y, which is equal to minus, we can take minus as a common factor, since arctangent is add, so it will be here minus arctangent x plus y over 1 minus x y. We flip. If we times by minus, we get here minus plus, here minus plus, and here plus. So we have minus p plus this. We take minus pi from this side, and we will get exactly this formula. We will repeat the same thing, exactly the same thing, but in this, the last case, with xy greater than 1, but x and y negative. If they are negative, here we will get firstly minus pi over 2 minus 8. When we times by minus, it will be positive. If we take it to this side, it will be negative. This is all. It was a little bit long. Thank you for watching. See you next time, inshallah.